Protocol buffers, or ProtoBuff for short, is a method of serializing structured data useful for transmitting data over the wire or storing it on the disk. In this video, I want to build an application with pure JSON, and then I'm going to rebuild the same application using protocol buffers. And finally, I'm going to compare the results in the context of the storage in this case, because I'm storing the data locally on disk, right? The size of the messages and all that stuff, right? And finally, I am going to go through the pros and cons of protocol buffers, because guess what? No matter how fancy the term sounds, there's always something bad about any tech out there. There's nothing perfect. If you're interested, stay tuned. If you're new here, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new video. With that said, let's just jump into protocol buffer. So I'm making this video because it's a prerequisite to another video I'm planning to make, which is called gRPC. And I found myself cannot make that video without actually talking about protocol buffer. So here it is, right? So protocol buffer is a message format, right? It's nothing really fancy. It's not as intimidating as it sounds. So I'm gonna demystify it right now. But in order to do that, let's talk about how we usually do things, okay? So I have here, I'm gonna build a JavaScript application using Node.js to, I don't know, build a list of employees. And think of this, maybe you read them from a table on Postgres and you're populating them in your Node.js Express server so you can send them over the wire, right? But this part is only gonna be a pure employees list, and there's a bunch of objects. So how about we build that? I'm gonna go ahead and create a brand new project, brand new spanking project here. Gotta call it ProtoBuff. So you guys gonna get the code later. And just create a new thing. JS file, index.js. So here's what we're gonna, how do we basically create an array? Let's just initialize npm and all that jazz. npm init -y. All right. And I'm gonna create a bunch of new employees. How do you create an array of employees? Very simple. It's JSON, it's beautiful. Just like that, you have an array. No type, nothing. And that's what made JSON a very attractive and very popular all these years, right? Because I don't need to specify any types. And we're gonna come to that. Okay, so how can I add a new employee? I can do this, right? All sorts of fancy stuff. I'm gonna create a new employee, get a name, and his name is Hussein, that's me. And people pay him $1,000 because he's poor a month. And what else? ID number 1 or 1001. How about that? So that's how we add employees, right? You can do it another way. Let's create another one called Ahmed. And I don't know, you can do it this way, right? So this very, very similar approach, right? You can do it this way. And this guy is named Ahmed, and Ahmed is way richer than Hussein because his dad have like 3 oil refineries or something like that, right? So he's rich, right? So let's add Ahmed to the list, right? And then you can add another. It's gonna add another employees here. Did I have it still copied, that thing? Yeah, I have it copied. Rick, okay? Rick owns like 5,000, right? And his ID is 1003. Beautiful stuff, guys, right? So this is an array. And how do you print stuff, right? We can let's go ahead and just print it so you can show you guys, right? So you can just do JSON.stringify employees, right? We can just print that stuff. Let's go ahead and debug that stuff. Okay, and you can see it's printed. Hussein, what are you doing? I don't get what you're doing here exactly. We'll get to that to the minute. Let's say I have this result now. I have this employee array, and I got it no matter how I got it. I got it from the wire as an HTTP2 request, right? Or I read it from a file, or I read it from a database, and I convert it into a representation. Now I have this array. I'm gonna write it to disk, just to show you guys how big this file is. It's a bunch of string of stuff, right? So how do we do file stuff? Require fs, right? And then we can do fs.write file synchronous, because I'm not in the mood to do callbacks right here, unless someone volunteer and do a promise-based file system library. I'm not gonna use the callback. I hate callbacks, okay? So I'd rather do that. So go ahead and write this stuff as a file. And what is the callback? What's the file name? Let's call it JSON data.json, and just throw it there, okay? Hopefully it makes it get thrown in the correct folder. All right, so something got written. So let's go ahead and check the file here. There you go, JSON data. Beautiful stuff, right? How big is this file, guys? How can I check how big is this file? So let's go ahead to the command terminal real quick. So if I go to the command terminal and do ls-lh, you can see that my JSON file is around 125 awesome bytes, right? So just for 3 employees, I have 125 bytes. And that might not be big, but think about going to the thousands. This goes large and large. And you're thinking about sending this data across the wire, across the HTTP protocol. Yes, HTTP2 does compress some stuff, but despite that, it's still quite large, right? Compared to what we're gonna show now. Okay, so now you saw me in few quick minutes, I was able to write an application with essentially JSON and JavaScript. How about we do the same thing, but with protocol buffer? So here's how we're gonna do the same example, but with protocol buffers. So protocol buffers are structured data, is representation of structured data. JSON is not structured data. You can just add anything you want here and JSON will not yell at you. You're responsible of the maintaining the correctness of a schema, right? It's not gonna tell you that, hey, you sent me a name here, but you said name 2 here or name capital. You're responsible of doing this. It's not gonna yell at you. This is a valid JSON as long as it stands. You don't have a specific hard rigid schema, unlike protocol buffers, which forces you to use a structured and a schema. Well, to do that, we need to build a schema. So you have to build this proto file, which we are about to build, and tell it that, hey, an employee looks like this. It has 3 properties, and the first property is this, and the second property is this, and the third property is this. And you can do it this way. You have to tell the proto file with the protocol buffer how the file looks like. So how about we do that? So let's go ahead and create a new file, and this file is gonna be called employees.proto. Okay, that's the extension of protocol file. And then when you do that, Visual Studio Code will yell at you, says, what the heck is a proto file? I never heard of this thing. I suggest you go to Search Marketplace. Okay, it's really good. You don't have to, but it's a good idea to install this Visual Studio Proto 3 thing. If you install it, it's gonna do an like an IntelliSense and tell you if your syntax is wrong while you're writing a proto file, and it will help you a lot. So how about we do that? So the first thing we're gonna do is you have to specify which version of the protocol buffers you are using, okay? Because this technology have evolved across the years, okay? Along the years. It's been developed, I think, 10 years ago, maybe 11 or 12 years ago, right? So it's been beginning better and better and better, okay? So the first thing you do is syntax, and that's what I'm talking about, right? It tells you that syntax equal proto 3, and you have to add semicolon at the end, okay? So that means I'm using the version 3 of the protocol, and that's the latest and greatest stuff, which there are some changes. I'm not gonna go through them, but essentially this is the latest version. And what we're gonna interested in is everything in protocol buffer. Most of the stuff is labeled as a message, okay? So my employee, it will be turned into a message, okay? So you're gonna create a message called employee, and this is just a single employee. And this looks very JSON-y, but it's not really a JSON. So Don't get confused. So my employee, in this case, I will create an ID, the first property of the employee. But it's a schema, it's a structured data. You're gonna tell me what type it is. So I'm gonna say integer 32. So that's the type of the ID. That means the largest number is, I don't know, 4 billion, wherever. No, it's actually more than that, okay? That's the 32-bit, right? It might be actually that, right? 4 billion, right? So ID, and you say equal 1. And that's the serialization sequence where every property you label it with the position of where it exact, and this is where the protocol buffer maintains the compatibility as you upgrade your file. Okay, so if ID is number 1, it knows that, hey, this is the number 1 property, this is the number 2 property, and so on. You have to label it sequentially, okay, uniquely also. The second thing is a string, and it's called name, right? And this is the second property, right? And the third one is salary, right? Float salary equal 3. Okay, so just like that, I created a single employee here. Okay, and if you have noticed, this is a single employee. How do I do an array? Because I need an array. This is just the single employee object, right? We're gonna create a single employee object, but I need to do also an array. So how do we do an array in protocol buffer? It's the same thing. We have to create a completely different array message, right? And this message in this case is called employees with an S. And this guy, when we create that class called employees, we will have an add function that we can add employees to that thing. Remember, guys, this is very similar to the push stuff we did here for the employees, right? You have to rebuild the entire thing with proto, but the beauty of the protocol file, protocol buffer, is the beauty of a protocol buffer is it is language neutral. So whenever we build it once, there is a magic fairy wand that Google built, and they say, woo, abracadabra, poof, it will convert into any language you want. And we're gonna show that magic now. So what I want to do is I want to create a repeated property of type employee, and the name of this thing is called employees, and this is the first one. Okay, and let's explain that. So the first type is here, right? So that the type of the property, in this case I want to create an employee object, and this is the name of the thing, and that's the first location, but I want this to be repeated. That means I want as many as possible, so that's the array equivalent, right? All right, guys, here's a proto file. How do I include it in my JavaScript file? Because we're gonna create a brand new JavaScript file. You know, guys, you know that, right? You know that, right? We're gonna create a brand new JavaScript file, index2.js. Okay, and that's just yeah, we're gonna create a new one, but I have no idea how we can import this proto file in my JavaScript. How do you do require proto? No, it's not that simple, son. Here's the thing. Let's talk about this a little bit. The proto file is just a file. It's just a schema definition about your messages and your structured data. Okay, you are responsible, based on the language of choice, in this case it's JavaScript, to convert this proto file into a JavaScript file that literally builds the class that is called employee, and build the class that is called employees, and add properties ID, and add property name, add property salary, and all that stuff, and does all of that stuff. But that just defeats the purpose. If I'm gonna build this thing, might as well, I'm not gonna use the protocol buffer. That is why Google built a cool thing called the protoc, which is the protocol buffer compiler. You feed it a proto file, you feed it what language you want the output as, and it is going to output the equivalent language. If you give it JavaScript, it's gonna give you a JavaScript file equivalent to this. If you give it Python, if you tell us, hey, give me Python, it's gonna give you a Python file, okay, with the same schema. If you give it a C++ output, it's gonna output a C++ file. And that's why it's language neutral. It's not agnostic, a little bit of a difference. You can't just use it, right? You have to do some work, So the work here is to do the compile this thing into a JavaScript file. How do we do that? I'm gonna have the link below in the description, guys. This is where you want to go. This is the official stuff, protocol buffers, ProtoBuff releases. And as of making this video, this is the final release. But I want you to go and find, ignore all that stuff. Find the protoc, the compiler for your operating system. It has nothing to do with the language here, okay? You're looking for either a Linux, Windows, or an OS. In my case, it's a Mac, right? So I'm gonna download the protoc, which is the compiler of the ProtoBuff files, right, on my Mac. So let's go ahead and download this sucker, okay? And if you're using Windows, you download this. If you're using Linux, you download this, or there might be an apt get that does all that stuff for you. So I'm gonna go ahead and download this stuff, right? Let's save it and then extract it, okay? It's gonna extract it somewhere, okay? And it's gonna throw it in the downloads, and that's fine, all right? You can do that. And here's the thing, guys. This is the file we want, protoc, okay? We want to execute that, and obviously to execute anything, you have to be in the same path. You can do some fancy stuff and add this as a system link. I'm not gonna do that just to make the video a little bit shorter. Okay, so I'm gonna just go to the location literally and just execute my stuff. How am I gonna do that? Okay, go back to my terminal here in the same location because I have the protoc, right? And here's what I'm gonna do. Where's the protoc file? It is on my users, Hussein Nasser, downloads, right? Protoc, that's extracted file, and then bin, and then protoc. That is my protoc, right? You can as simple as just have the same file. Now this in your Windows are gonna be .exe, whatever, right? Okay, the next thing we're gonna do is do -- JS_output. I want the output to be a JavaScript, right? That's the output. But there are multiple import formats. There is the Google way of importing stuff in JavaScript. There is the CommonJS, and hopefully one day the protocol buffer will do the module, the import export ES6 stuff, right? It's not there yet. I really hope that it's coming soon because ES6 is gonna be the standard finally, right? But until it comes, we have to use this CommonJS thing, right? So we're gonna do import _style and then equal CommonJS comma binary and then colon dot space employee dot space employees dot proto. So that's the input proto file, right? And this is what we want, the output. We want the CommonJS, and hopefully let's just click enter and hope for the best, and it's done. Look what it threw up. It threw up an employees _ protocol buffer.js, which is the same name as the protocol, and it has code, and it is everything that we need to do this thing, guys. It is everything we need. So let's start building all that stuff. Let's go ahead and use it, guys. How about we use it? Okay, so there will be an employee class. There will be an employees with an S class. So let's start using it, guys. So I'm gonna do a change here on the debugger thing, so we can, right? The debugger is pointing to index 2, so that's our brand new stuff, right? So here's what we're gonna do. One thing we need is we need to install this thing, the Google ProtoBuff runtime, right? And this is very simple to do. You can do npm install Google-ProtoBuff, right? So that's just the runtime that Google needs to install that stuff. And I promise that's the last thing we're gonna install, and that's it, right? So runtime ProtoBuff, right? I'll have the commands in the description, guys, for you as well. All right, so what do we need to do? We need to import. Now I can import this stuff. I can import my beautiful schema. So how can I do that? I'm gonna create an object called schema. I like to call it schema because the whole thing is a schema, right? And where do we do it? Dot employees ProtoBuffer. That's the exact same file that we're importing. Okay, and here's what we're gonna do. I'm gonna create a new employees, right? Employees. I'm gonna create an employee called Hussein, and the employee, now you're just gonna use a new because you're creating a new object of this thing, just like creating classes, exactly like classes here, right, guys? So schema dot employee, right? We just created a brand new one. All right, so what this is essentially, you will have a bunch of functions that will be auto-generated for you on this object. And unfortunately, Visual Studio Code for some reason is not showing that stuff, but it's functions. Like there will be a function called setID, and you give it the ID like that. Okay, there will be a function called setName, and you give it the name, and there will be a function called setSalary, and 1001. Let's go ahead and just print this thing. My name is, I don't know, just Hussein.getName, right? This is the first employee. I just want to make sure it actually works, right? There you go. My name is Hussein. Still nothing is fancy here. Hussein, what are you trying to do? All right, I could have done this myself. I could have created a class myself, but you will have to do a lot of work to do that, right? The protoc does this most of that stuff for you, and the protoc is the template where you can create all this beautiful stuff. Okay, we need more than this, guys. This is not enough. This is not enough, right? We need to create Ahmed. We need to create Rick. Let's create Ahmed and Rick. Ahmed, rich boy. Jeez, all right. Where's the rich boy? Is it really 1001? Okay. Why is my salary 1001? This guy's like 9,000. Okay. And then Rick. Poof, 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 poof. Rick is on 3. And then Rick earns what? 5,000? Was it? Okay, whatever. Cool. Now we need to create a bunch of employees array and then add this stuff to. How do we do that, guys? We do const employees equal, who guessed it? Who can guess it? Schema.employees. We do have a class or a message that is called employees, right? So I can do that. And when you create a repeated thing, you're gonna get a function for free called add and then employees, right? And if you ever, you can always look at the code. Like I cheat all the time, right? Because I don't know the code, right? Add employees. So that's the function right there, okay? With other languages, you'll always get IntelliSense, so you'll not have this problem, but sure. Add employees, I'm gonna add Rick. Doesn't matter the order, we'll just add them in order so we don't have anything here, any problem. Ahmed, rich boy, all right. All right. Now we have a bunch of employees. That's good. I love this. I love this a lot. So the final thing we want to do here, guys, is showing you how can we deserialize this, or actually serialize this into binary, because binary is what we will store to disk, because binary is what we will send across the wire. And this is the power of protocol buffer. This is the most powerful thing here. Cool stuff. Let's do that. So what we want to do essentially is let us serialize this now into a binary, right? Binary plus, and we're gonna do employees dot serialize binary. Hope I spelled it right. And that's it. Literally, this will return. This will convert into a binary and will return. There is another function called deserialize, which will deserialize the binary that you give it, the bunch of bytes, into actual data, right? Actual classes and objects, right, that you work with. And just for fun, we're gonna do this, right? So we actually know that we're getting a bunch of bytes. So if I do this and run, boom, look at that. It's a bunch of bytes, 0101 68, and essentially the decimals right here by default. But let's write it to disk. That's our test, right? Const fs equal require fs, right? And then we're gonna do fs.write a file sync, and then just write bytes, and let's call it, what do we call it? Let's call this employees proto bytes, just binary. I don't know. Is that what we call that? Okay, employees binary. So let's go ahead and both write it. Okay, so now we have the employees binary, we have the employees, the JSON data, right? That's the JSON version, that's the employees version, and we can't obviously open it, right? It's just the binary data. But let's look at the size of this thing, guys, and compare it, right? Maybe just rename it to binary data, so we just look at side by side. Go back to the terminal. If I do this, let's look at this. Employees proto, I don't care about that. Binary data is 52 byte. The JSON data is 125 byte. Oh my God, how much this? This is like almost 2 times smaller. Okay, so that's the benefits of the protocol buffer. It's so compact. So if you send it, you will avoid this extra round trips, especially these TCP round trips that it does, right? This annoying slow stuff, right? So protocol buffer, very, very useful, right? Because you're gonna get a smaller format. And then, all right, so let's actually just deserialize these bytes back to actual objects and print them. We can do that, definitely, right? So we know that the object that we serialize is the actual employees class, right? So that's a very important thing. So what we're gonna do here is const employees to an object, right? Equal schema dot employees, right, with an S, dot deserialize, always misspelling thing, man. Bad English. Deserialize binary, and then you pass it the actual bytes that we received, whether we received them from an HTTP call or read them from a disk, right? You might want to consider protocol buffers as a storage mechanism, because they will save you huge amount of data, all right? Disk, as we showed, right? So let's go ahead and print that thing. Console.log employees 2. Let's just print them, and then if I do that, print, go, 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 go. Poof, 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 poof. Yeah, we don't have to do all that stuff. Yeah. Look at that. We got it back. Print it. Look at that beautiful stuff. A bunch of employees. That's what we got back. Well, we got as an object because we didn't convert it into a string, right? So we can just do it like, I don't know, force it to convert to a string by either doing toString, right? That will actually throw them, right? All right, guys, that was the example aspects of this. Let's talk a little bit about, finalize this video by talking about the pros and cons of protocol buffer, because as nothing is perfect. Let's just discuss this thing. Okay, so one of the benefits of protocol buffer is actually having a schema. A lot of people prefer this stuff, especially back in the days. Their only languages that existed are strongly typed languages like C++ and C# and VB.NET, right? And VB6, even VB5 was strongly typed. Most of the languages were strong. Java, right? All strongly typed. They need to, hey, you cannot declare just a variable by just using var or const, right? This is the beautiful days of Python or JavaScript, right? This didn't exist back in the days. So what the schema, a lot of people prefer schema because they need their data structured. Not everybody like that, but it is still, you just satisfy those people by giving them a schema. Because schema, when you know the schema, you can do so much optimizations. You can make your data efficient. You can store them more efficiently. You can store them. You know how to read them, right? You need a schema. And you get more and less errors as well with time. It is the second advantage of protocol buffer is it is compact size. It is extremely small right, footprint. It has a small memory footprint, it has a small disk footprint and network footprint, right? If you send it across the wire, it's binary and it's so small, so you can send it, and the HTTP2 actually will add an additional compression, which will make it even smaller, right? If it can, right? Which is awesome, right? And the third one is actually language neutral. So this proto file that I built here, right? If you don't like JavaScript and you hate it, right? I can give it to you and we can talk and we can agree. This is like almost like a language by itself, right? Because I give you this file, you use proto-C, right? And you say output Python, and it's gonna output very similar file to this, but instead of employees_pb.js is gonna be employees_pb.py, right? And then that's it. You're gonna start using that stuff, right? And then just build your classes very normally. So, and if you're Java or JavaScript or any other language, it's the same thing. So it's a language neutral protocol format, and that saves a lot of trouble. Okay, so that's another beautiful thing, and gRPC is built on top of this thing, and that's the key, guys. Here, that's the key. The being language neutral is very, very powerful. Yet, still, Google has took it upon themselves to build us the compiler that actually spits out the language of our choice, right? If that didn't exist, this thing is useless, to be honest. Nobody's gonna use it if proto-C didn't exist. Let's be honest, right? The cons. What's bad about this? What's bad about this? Well, I couldn't find a single thing that is bad about this, right, by searching the internet. For some reason, people really love it. But, right, if I really can squeeze my head and think really hard, what I don't like about Protocol Buffer is, look at this. Compare the time I took to build this example versus the time I built this example, right? Almost 3 times slower, right? Because I needed to do all that garbage of writing a proto file and compiling it and blah, right? Just to write a beautiful code, right? If you know your language, right? You will not use all these extra files and put it on your code and make sure you have to always upgrade that stuff every time, because this can have bugs, right? And Google are responsible to eventually maintain that. But guess what? It's in your code. So you have to do a proto-C every now and then to first you have to update your proto-C file, right? And when you do that, Google will essentially patch some bugs, security stuff, right? And any inefficiencies they are doing with the compiler, and they're doing all that stuff for you. So you have to regularly update this code by doing a recompilation of the proto file to generate the new JS, and that might break your code. That might do certain things, right? It's not perfect, right? Nothing's gonna be perfect, obviously. Right? So it might generate some undesired behavior for you that you do not like, right? So just pay attention to that, right? Proto-C, maintaining all that stuff. So it's always easier to, if you will know your language and you're doing small stuff, you don't have to use Protocol Buffer, right? So that brings us to the second point, right? The second part is, I don't really care about having a schema. You are forcing me to have a schema. I do not like that. Mind you guys, reminding you that why people moved from SOAP to REST. There are 2 reasons people moved from SOAP, the Simple Object Access Protocol, to REST. The first one is the atrocious XML format that the creator of that protocol forced us to use, which is so big. It's just twice as big as JSON. Okay. But the second thing is also the schema. Some people don't like to use schema. They want to build a small application. Look at all the tutorials on YouTube, for God's sake. Right? It's just, if all those to-do lists are built with schemas, people will hate themselves. If you're building really small application, sometimes you don't really need a schema, and using a protocol buffer will be an overkill for you. Okay, so if you really need to think about it, do you need a schema? Yeah, then use protocol buffer. If you really don't need a schema, I'm fine with JSON, and I'm not gonna take the bloat of protocol buffer and maintaining all this extra file and having to maintain a proto file. Remember, because you're responsible for the schema, right? The moment you have it, it's not having a schema is not easy, right? Having a schema is hard. You have to maintain it, and you might change the format, and some people might yell at you. Your clients will yell at you. I mean, your clients will yell at you regardless. What do you do? It's the circle of life. There's no escape from that. All right, guys, I think that's it for me. All right, so we kind of throw some shade at protocol buffer, but I kind of like it. I love it. I like it. But it depends. I'm not going to use it all the time, okay? Because this is the terrible thing I have to go through just to do one thing. It's just a lot of work, I think. Yeah. Some people might disagree with me and says, "Hey, Hussein, you're just you're just lazy." All right, guys. Hope you enjoyed this video. Gonna see you in the next one. You guys stay awesome.